Hi everybody. This week we are going to look at graphing the vertex form of quadratic functions. So this folder that you're looking at right now, it's relatively shorter than the ones we normally have. And this is expected to be done by May 6th. Sorry, you hear my kids in the background. So this is for May 4th through 6th. After this folder and after this date, I will upload um, another folder for May 7th through 8th. And that's just a short lesson on how to form or how to graph another form of quadratic function. So to begin with, you always have that cumulative review in the beginning of each folder. And the two main topics for these folders are identifying odd and even functions and how to graph a vertex form of quadratic function. The expected outcome, the overall output of this lesson is, the same graphic organizer that we've been using in the past three lessons, modified a little bit to show the necessary information that's needed in this type of quadratic function. Okay, so go ahead and do the cumulative review. So again, the items in this folder must be completed in sequential order. So that means you will start from cumulative review and then go to the next one and the next one and so on. Do not follow the order in which they appear in the gradebook because depending on whether they're a classwork or an assessment, they may be arranged differently. So make sure you go to materials and then follow the order as they appear here. Okay, so assuming you have already worked on cumulative review, I'm going to start discussing odd and even functions. So how do we know whether a function is odd or even? Now, by definition, a function y is equal to f of x is even when f of negative x is equal to f of x for each x in the domain. And the graph of an even function is symmetric about the y-axis. So what does that mean pretty much in simpler terms? So a function is even if the function is the same as the original one, even if you replace x by negative x. For example, let me see if I can write it this one. So let's say, for example, I have f of x is equal to x squared. If I change the x to negative x, I will get negative x to the second power. But negative times negative is again positive. So the parent quadratic function is an even function, and that's why it is symmetric with respect to the y-axis. However, let me erase this one. However, some functions are odd. So what do we mean by odd? Let's read this one first. A function y equals f of x is odd when f of negative x is equal to negative f of x for each x in the domain. The graph of an odd function is symmetric about the origin. A graph is symmetric about the origin when it looks the same after reflections in the x-axis and in the y-axis. So what does that mean? For example, let's take a look at the function that is linear. Let's say f of x is equal to x. So this is the same as y equal to x, right? Which is the linear function. So if I change the x to negative x, this will become negative of x. So it says right here, if you replace the original x by negative x, then the resulting function is the opposite of the original. So earlier it was x and then it became negative x, so they are opposites of each other. So that's the difference between even and odd functions. We're going to look at some more examples to illustrate the difference between the two. So let's take a look at this one. So letter A, Let's replace x by negative x. So the original function is 2x. So I copy the 2, and then instead of the x, I make it negative x. So if I simplify that, I will get negative 2 times x. So is this the same as the original function? No. Did it become the opposite or the negative of the original function? Yes. So that means this function is odd. How about letter B? I get g of x is equal to x squared minus 2. So let's replace x by negative x. So instead of x, I put negative x and then square it and then subtract 2. Just like what I mentioned earlier for the parent quadratic function, negative x times negative x will become positive x. So it will be x squared minus 2. Did it end up to be the same as the original? Yes, so that means this function is even. Now for letter C, I got h of x is equal to 2x squared plus x minus 2. So let's replace x by negative x. So I have a 2 at the beginning, change the x to negative x, and then this becomes negative x take away 2. So negative x times negative x is positive x squared, so this will turn out to be 2x squared. Positive times negative is going to be negative x, and then negative 2 is negative 2. So what happens here? This ended up to be the same as in the original, while this changed to its opposite and this changed to its original. So pretty much the whole thing is not the negative of the original function. So that means this function is neither odd nor even. So I do hope that those examples helped you learn how to differentiate odd and even functions. So go ahead and do the exercises right after the notes and videos that you saw. So do odd and even functions exercises, and then later on come back here for another screencast on how to graph the vertex form of quadratic functions.